from UFOs to possible
The best proof yet.
Life on another planet.
K2-18b
could be home to life.
On April 17th, NASA unveiled findings that shook the scientific world. Buried in the data was evidence pointing to something extraordinary. Strong signs of life on a planet far beyond our solar system. That planet is K218b, orbiting a faint star, nearly 124 light-years away. Within its thick atmosphere, scientists detected chemical compounds that, on Earth, almost always trace back to living organisms. What makes the discovery even more staggering is the concentration thousands of times higher than anything found on our own planet. The clues suggest K to 18 billion may not be barren rock or dry desert, but a vast water world with endless oceans that could cradle entire ecosystems. If life truly thrives there, what kind of creatures might exist in those alien seas? Could this be our first glimpse of another living world? Let's break it down. In 2015, as the Kepler Space Telescope began its K2 mission, its lens swept across the dark reaches of space, searching for distant worlds. Over time, it cataloged more than 1,200 planets, each carrying secrets about the universe. Yet among this vast collection, one stood apart. A planet far larger than Earth, carrying a mass nearly 9 times greater, seemed to show hints that it might be habitable. It was named K218b, and from the beginning it stirred both curiosity and hope. 2 years later, in 2017, the Spitzer Space Telescope added its own observations. Spitzer confirmed that K218b orbits its star within the narrow habitable zone, where temperatures could allow water to remain liquid on the surface. In Chile, astronomers working with the HARPS spectrograph began to refine the picture further. Their findings suggested that the planet's density hinted at the presence of an ocean. With each new piece of evidence, the possibility of life seemed less like speculation and more like something tangible. By 2019, Hubble Space Telescope took the investigation even further. Sensitive instruments revealed water vapor in the atmosphere of K218b. This was no longer an abstract hypothesis. The discovery meant that the world might not only possess oceans, but also the right conditions to support life. For the first time, the dream of an inhabited ocean planet orbiting a star far from our own seemed within reach. The story took another dramatic turn in 2023, when the James Webb Space Telescope, the most advanced instrument of its kind, turned its powerful eye on K218b. In the filtered light of its star, scientists found the signature of a chemical compound that startled the scientific community. Dimethyl sulfide, or DMs, appeared in the data. On Earth, this substance is produced almost entirely by living organisms such as phytoplankton and marine microbes. The thought that such a signal had been detected on a world over 100 light-years away electrified astronomers. But there was hesitation, too. The reading had been captured by a single instrument aboard the James Webb, its near-infrared camera, and distinguishing dimethyl sulfide from similar gases such as methane is an extraordinary challenge. Scientists knew that the possibility of an instrumental error or a misinterpretation could not be ruled out. A discovery of this scale demanded absolute certainty. To resolve the question, NASA prepared to repeat the measurement with a different instrument and a different method. On April 17, 2025, the James Webb once again focused on K218b, this time using a camera that operated in the mid-infrared range. The results sent shockwaves through the research community. Methyl sulfide was detected once again, and in staggering concentrations possibly 1,000 times greater than on Earth, on our planet. EMS is not only what creates the unmistakable scent of the ocean carried on the wind along coastal shores, but it is also a substance with a fleeting presence in the atmosphere. It survives only for a matter of days before being destroyed by sunlight and oxygen. For dimethyl sulfide to persist, it must be constantly replenished. And on Earth, that replenishment comes almost entirely from living organisms. The levels observed on K218b demanded a source of immense scale. The discovery carried enormous implications. To detect the chemical signature of a gas produced by life from such a vast distance sounds almost impossible. A small traveler slips in from deep space, and 3 scientists say it isn't a stone at all, but a mask. Harvard astrophysicist Avi Loeb and his team point to an object cataloged as 3I Atlas, arguing that what looks like a comet could be engineered. Hardware. Their claim sits on a formal paper linked with NASA titled, "Is this interstellar object 3I Atlas alien technology?" Where the math, the path, and the timing build a case that feels hard to dismiss. The object's trajectory hugs the orbital plane of the planets. Threads past multiple worlds, and soon will slide behind the sun, a vanishing act that raises even more questions. Decades ago, Stephen Hawking warned against shouting our presence into the cosmos. For more than a century, radio noise has spilled from Earth like a beacon. NASA labeled the visitor a comet at first, then mapped its motion with detailed illustrations. While Loeb's group now pegs the likelihood of a spacecraft at 99% and points to a shield interceptor concept taking shape. So, tonight's video follows the trail of data to see where it really leads. A new arrival has slipped into the solar system, and its behavior is stirring debate that stretches far beyond the world of astronomy. First estimates suggest this interstellar object could be as large as Manhattan, perhaps 20 kilometers across, though Harvard astrophysicist Avi Loeb believes the true size may be smaller, hidden inside a veil of dust and vapor. What cannot be hidden is its velocity, racing at nearly 255,000 kilometers per hour, or more than 150,000 miles per hour. It travels at a pace no natural comet of its size could possibly sustain without help. At that speed, it could sweep across the entire United States in less than 2 minutes, a scale of motion that alone sets it apart from any comet known to science. For Loeb and his colleagues, speed is not the sole concern. It is the pattern of its journey that makes the object. Even more intriguing, its orbit lies neatly within the flat plane that contains all of the major planets, still placed deliberately into alignment with the architecture of the solar system. The path takes it unusually close to Venus, Mars, and Jupiter, and those close approaches are not random encounters. In spaceflight, such passages are carefully planned to draw momentum. From a planet's gravity, known as slingshot maneuvers, they allow a craft to accelerate or alter direction without expending fuel. To see a natural object achieve such a sequence of assists by coincidence is so rare that Loeb's team places the odds at 1 in 20,000. The timing is equally suspicious. Its entry point into the inner solar system comes from the direction of the Milky Way's crowded heart, a region filled with stars and background glare that makes early detection difficult. That is why astronomers only noticed it in July of this year, when it was already well inside the planetary zone. Its closest approach to the Sun will take place at the end of October 2025. At the precise moment, Earth will be hidden behind the Sun on the opposite side of its orbit.